Hello and welcome to our next topic, that is solving of a linear problem using graphical method. So today we'll be taking a linear problem that we will be solving through graphical method. Now before we solve it using graphical method, we should know that there is another method that can be used for solving a linear problem, which is called simplex. Now given a choice, we should always go with the graphical method because it is an easier method, it is a smaller method, it is a method that consumes lesser time, and simplex is actually a method which is very complex in nature. It is very prone to errors. The calculations are such that there is a high probability of creating errors. So given a chance, you should always go with graphical, and if you are stuck with a situation where graphical cannot solve your problem, you should go for simplex method. Now how do we decide whether we can solve it using graphical or simplex? If you remember the formulation of a linear problem, then we saw our second step was declaration of decision variables. So decision variables, so long as you have two or less, you can go with graphical method, and if you have more than two, that is 3, 4, 5 or whatever, then you have to go for simplex. There is no way graphical can solve your question. The problem is, in graphical method we have two axes. We have an x-axis and we have a y-axis. So if you have two variables, one can be taken as x, another one can be taken as y, and we can solve the given problem. But if you have more than two variables, we cannot solve it using x and y. So whenever you get a linear problem, look for the number of decision variables. What are these? Decision variables. If your decision variables are two or less, you can definitely go with graphical, and if they are more than two, you are forced into a situation where you have to solve the given problem using simplex. So this was how to make a choice of solving a linear problem, either using our first method, that is graphical, or using our second method, that is simplex. So we have two methods which can be used. Now we'll proceed ahead with graphical method. Today we are learning graphical method. Now what happens with graphical method is, we plot a graph. Before we jump into a problem, first let us clear out certain basics of how a graph is created and what rules should be followed. For the purpose, let us draw a coordinate system over here, and then we'll see how we can plot it, a graph. Let us say this is our system, and because this is our first question, let me take an example. Suppose we have been given a constraint of 2x plus 3y less than equal to 6. How do we plot this constraint on this graph? It is 2x plus 3y less than equal to 6. First things first, we cannot plot less than or greater than areas. We cannot solve these. So in order to solve these kind of inequalities, what is this? This is an inequality. Why is this an inequality? Because left hand side and right hand side are not equal. They are less than each other. Left hand side is less than right hand side. It can be equal, but more often than not it will be less than. So it is an inequality. So first thing is, we need to convert this inequality into equality. Very simple. 2x plus 3y, just ignore the less than sign. 2x plus 3y is equal to 6. So this inequality has been converted into equality. Right? So this is an equality. Now if you remember, we can solve this equation and find out certain coordinates on this. In order to solve this equation and find out certain coordinates, let us make a table, let us say of 3 rows and maybe 3 columns. Okay, so here we have a table of 3 rows and 3 columns. Now let me put x over here, y over here, my first point and second point. Now have a look at this equation very carefully. In this equation, if I put x is equal to 0, in this equation, if I put x is equal to 0, what will be the scenario of y? X is equal to 0, you have to say 2 into 0 plus 3y is equal to 6. So this term becomes 0 plus 3y is equal to 6, or rather 3y is equal to 6, or in simple terms y is equal to 2. Fine. So this is our first coordinate. What happens is, in order to plot this inequality, we need to find out certain points. In order to plot this inequality, first we need to plot a line. What is this? This is less than. We will come to this. For now, we are plotting this line, and in order to plot this line, we need 2 points. This is my first point. Okay. Now let me find out another point. How do I find out another point? Let me put y is equal to 0. This is the simplest, easiest mechanism. First put x is equal to 0, then put y is equal to 0. So in this equation, this given equation, 2x plus 3y is equal to 6. If I put y is equal to 0, it becomes 2x plus 3 into 0 is equal to 6. That is 2x plus 0 is equal to 6. That is x is equal to 3. So when I put y is equal to 0, I get x is equal to 3. This becomes my second point. So these 2 points are required in order to plot this given equation. Now let us see where are these points. What are these points? x0 and y2. Let me declare this as y, this is x. X will be 0 and y will be 2. x0 on this complete line, x is 0. If I come here in this area, x is 1. If I come here, x is 2. If I come here, x is 3. If I come here, x is 4, 5. Where is x is equal to 0? It is here. So I need some place where x is 0. X is 0 on all these. And y should be 2. So this is my point. What is this? X is 0 and y is 2. Similarly, I need a point where x is 3 and y is 0. X is 3. Remember, we said that this is a place where x is 3. Everywhere on this line x is 3. So we can take any point. But along with x is equal to 3, I need y is equal to 0. Where is y is equal to 0? Here. So this is my another point. So these 2 points, if you connect them, you will get your first constraint. Let me connect them. We've connected them. This is our first constraint. We had only one constraint. Now, what is this? This is 2x plus 3y is equal to 6. If we give them some names, this is first constraint, so this is first constraint. Now look very carefully. The constraint was 2x plus 3y less than 6, and I have plotted 2x plus 3y is equal to 6. So where is this less than point? A very simple method to identify the less than point is, first thing, 2x plus 3y, this complete line is this complete line that we have drawn. This is 2x plus 3y is equal to 6. So one of the areas, if you can see, this line has split our system into two. One is this area which is on one side of the line. Another one is let us take this color. Another one is this area. So we have two areas, an area shaded with blue, an area shaded with red. So which one is less than? I need 2x plus 3y less than. So let us make a very easy, simple to remember thumb rule over here, that less than area is the area towards origin. Now if we have a look at this figure, coordinate system, this is my line, this is my line, and this is one area and another one is this area. So I have, this line has divided areas into two. I need less than area. Less than area is the area towards origin. This is the area towards origin. This is my origin. So this is the origin and this area becomes less than area. So while solving the linear problems graphically, if we come across a less than inequality, this will be my valid area, and in the very same question, if this inequality became greater than, then this would have been my feasible area, my acceptable area. Fine. So this is how this equation goes. Now just for practice sake, let us take one more question. Very quickly we'll solve that one because probably now we are practiced. Let us take 2x minus 3y is equal to, not is equal to, let us make it greater than is equal to 6. Now while plotting these graphs, one thing you should always remember is that RHS should always be positive. If it is not positive, make it positive. How do we make it positive? You take this 6, if this were a minus 6, how can we make it positive? You take this 6 over here and bring this x over here. Now do I have right hand side, or rather 6 as positive? Yes, this 6 has become positive. Right hand side is these numbers and left hand side is my equation. So my equation can have negative values, but my right hand side should be positive. Now if I rewrite this equation, it becomes minus x. Remember, it is less than, and then this is 6. So what I have done is I made a right hand side as positive. Okay. So this we should take care that right hand side can never be negative. For now it is not negative. I was just telling you, if ever we come across a situation where our right hand side is negative, we should flip them. Anyhow, now can we plot this inequality and find out the acceptable region? Let us go on very quickly. We'll make a table, and then we know that we need to find out values of x and y. We need to find out 2 points. How do we find those 2 points? First, we put x as 0 in this equation. 2 into 0 minus 3y is equal to 6. Remember, we cannot work on inequality, so we need to convert it into equality. Put x as 0 it becomes minus 3y is equal to 6, that is minus 3y is equal to 6, that is y is equal to minus 2. And then we have second point where we put y as 0. So this equation will become 2x minus 3 into 0 is equal to 6, x is equal to 3. Fine. X is 3. So these are my 2 points. First point, second point. Remember very carefully, students make an error of calling this as their first point and this as their second point. If I call this as my first point, I'll be plotting it as 0, 3. And if I take this as second point, I'll be plotting it as minus 2, 0. So remember, this is not my first point and second point, rather this is my first point that I'll plot and this is my second point that I'll plot. Now this time we have certain negative values also. So we'll have to take our coordinate system a little differently. Let us go ahead and plot it. Right? So this is x and this is y. Now if you remember from your early days of schooling, these are minus x and minus y. So my first point is 0 and minus 2, that is x is 0 and y is minus 2. X is 0 and y is minus 2. Let us put them 1, 2, 3, minus 1, minus 2. And here we have 0 and minus 2. X 0 and y will be minus 2. This is our first point. Then we have x3 and y0. x3 and y0. So this becomes my constraint. This is my constraint. Okay. Now this constraint, if you remember, this is 2x minus 3y is equal to 6, but I need 2x plus 3y greater than or equal to 6. So remember, less than area is towards origin. Where is my origin? This is my origin. And origin is on this side. We have our line over here and the origin is on this side. Here we can see, here is our origin. So this is less than area. Remember, less than area is the area towards origin. So towards origin I have less than area, but I need more than area. So where is my more than area? This is my more than area. So this is the region acceptable. This is acceptable solution to me. Fine. So this is how we plot the constraints. If it is less than, find the area towards origin, and if it is greater than, find the area away from origin, not towards origin but rather away from origin. This is how we will be plotting these constraints. Now there can be a little variation of these constraints. Let us take that variation also and then we'll go to certain questions. Probably in next video. In this video we'll just learn how to plot these constraints. Now a variant of these constraints that we can come across is when we get something like this. X plus 2y is less than or equal to 0. Now here we need to look carefully. X plus 2y is less than equal to 0. First things first, I cannot work on less than, so let me convert it into x plus 2y is equal to 0. Next what I do is, I make a table where I'll have x, y, first point and second point. Fine. Now, how do we go about it? Remember, put x is equal to 0. If I put x is equal to 0, it becomes 0 plus 2y is equal to 0. So, 2y is equal to 0, giving me a y is equal to 0. Now, when you put x is equal to 0, you get y is equal to 0. Now, we are in a fix, because if we put y is equal to 0, obviously we will get x is equal to 0. So, they both will give me same points. Don't get it? Suppose we put y is equal to 0. So, this equation will become x plus 2 into 0 is equal to 0. X plus 0 is equal to 0. X is equal to 0. So, in this case, both are giving me, if I put y is equal to 0, I get x is equal to 0. Now, this is not a solution. I need 2 points to plot, but I am getting only 1 point because these both points are same. So, what I will do is, in these kind of problems, where you have RHS as 0, these are little typical ones where we cannot follow our rule of less than area being towards 0. We cannot exactly follow this rule. We need a slight variation of the rule, and that variation would be, first things first, let me find out the second point also. Now, how do I go about my second point? I'll play a little trick over here. What I'll do is, I'll not take my point to be 0 itself. I'll take, let us say, x is equal to 2. If I take x is equal to 2, this equation becomes 2 plus 2y is equal to 0, 2y is equal to minus 2, y is equal to minus 1. So, here I get y as minus 1. Now, I have 2 points. Here is my first point, here is my second point. Let us go ahead and plot these points. For the purpose, I will be needing a coordinate system. First, let me plot the coordinate system, then we will plot the points and then the constraint. Here is our coordinate system. Let us plot this constraint 0, 0. So, my first point comes over here 0, 0. Both are 0. Remember, here is my point 0, 0. Then x will be 2 and y will be minus 1. X will be 2 and y will be minus 1. So, where is x is equal to 2? X is equal to 2. All this is x is equal to 2. Where is y is equal to minus 1? All this area is y is equal to minus 1. Area, rather, line. This is y is equal to minus 1. So, where is that point where x is 2 and y is minus 1? This is that point where x is 2 and y is minus 1. Right? So, I have my point. Can I go ahead and plot this? Definitely. I have my first point, I have my second point. This becomes my constraint. This is my constraint. It was slightly bigger. Here we have. This is my constraint. Now, what is this? This is line. Remember, this is not area. Rather, it is line. What line? X plus 2y is equal to 0. This is the line. Now, I need less than area. Now, my rule was that less than area is towards the origin. So, this is towards origin or this is towards origin. Now, the problem is, the catch is, the thing that has gone wrong over here is that my line itself is passing through the origin. So, what is towards the origin? The line itself is on the origin. So when the line itself is on the origin, how do I find out towards the origin area? Now here we have a new rule, a slightly different rule, that will be look at the value of, look at the sign of x. What is the sign of x over here? Positive. So on positive x side we will be having the greater than area. Okay. So my new rule would be, where can I put this rule? I'll put this rule over here. When RHS is equal to 0, then look at signs of variables. Look at signs of variables. Their respective axes are in greater than area. Their respective axes. Now if we have a look at Rx, it is positive. This is positive x. Y is also positive. Y. So this is my greater than area. Very easy. Look for x and y. X is positive. Y is positive. So this is my greater than area. Was that easy? And if my x were negative, in that case this side would have been greater than area. Is that simple? Is that easy? Can we work that out? Now just remember, we have two situations. One is where RHS is some number. So if it is a number, my golden rule is less than area is towards origin. Now if someday it happens so that your RHS becomes 0, if RHS is 0, then how do I find out less than or greater than area? Look for the signs of these variables. X is positive, so wherever you have your x positive axis, that will be your greater than area. So this is my area. This area becomes greater than. This is my greater than area this time. Fine. Now look at this situation once again, a slightly altered scenario. Right now we had an equation of x plus 2y less than equal to 0. Now suppose we had an equation of minus x minus 2y less than equal to 0. Look here, x plus 2y less than equal to 0. Now I have made it minus x minus 2y less than equal to 0. What I have done is I have converted these positive signs into negative. We are just taking another example. Now if you convert it into equality, you will get minus x minus 2y is equal to 0. What will be your points? If you go ahead and try to find out those points would once again be, let us say, we have x, we have y, we have first point, we have second point. If I put x as 0, it will become minus 0 minus 2y is equal to 0. So it will become minus 2y is equal to 0, giving me a y is equal to 0. In second point, suppose I put, again we are stuck with that situation, same situation as we had over here. So let me give y x is equal to maybe 2. So if I put x is equal to 2, then what happens here? We get minus. Remember, this is minus and x has been substituted as 2. So we get minus 2 minus 2y is equal to 0. So we get minus 2y is equal to 2, y is equal to minus 1. So when I tried giving x is equal to 2, I got y as minus 1. 2 and minus 1, 2 and minus 1. So this means that both these scenarios are kind of similar. X plus 2y is equal to 0 minus x minus 2y. If you look at it very carefully mathematically, it is x plus 2y is equal to 0. If I take minus x and minus 2y on this side and 0 on this side, so it is x plus 2y. So ultimately when we are working on same line, we are bound to get same line. But as far as inequalities are concerned, we had a less than over here, we again have a less than over here, but regions probably might switch. Now look here, x plus 2y less than 0. Remember what I said? Look for sign of x. Match this sign to its axis and that will be greater than. X is positive, this is greater than area. This area is greater than. And what happens to this? Obviously this becomes lesser than area. For which example? For this example. Fine. Now if I try making the same coordinate system over here once again, then let us see what happens. Here is our coordinate system. What are the points? 0 and 0. The first point being 0 and 0. Where will I have my 0 and 0? Here I will be having a 0 and 0. Then my second point is 2 and minus 1. X should be 2 and y should be minus 1. X should be 2 and y should be minus 1. This is my point. Okay. X should be 2 and minus 1. This is my point. Now if I connect these 2 points, I get my line that I have used. This is the line. What line? The equality. What was that equality? Minus x minus 2y is equal to 0. Minus x minus 2y is equal to 0. Now see, this was x plus 2y is equal to 0. Now I have a very same line, same 2 points, but now this is representing minus x minus 2y is equal to 0. And as for area, earlier we had plus x less than. So plus x, this is bound to be greater, so less was this one. Now this time I have minus x. So this minus x is telling me that all this area, that is minus x. Remember, this is minus x. So this minus x is telling me that this minus x area is larger than. So where will be my smaller than area? This is my smaller than area. Fine. This is smaller than. Now if we compare these two cases, we had greater than in an earlier case, but now I have smaller than. So we need to look at these constraints very carefully. Now if we have a very good idea of these constraints, we can go ahead and solve the problems. Is that fine? So in next tutorial when we meet, we'll try to solve proper linear problems using graphical methods. I believe this lecture was necessary so that we can work out how to plot these constraints and how to work out the less than and greater than areas. This is less than, this is greater than, and this is lesser than. So we need to work out these areas. PDF of this complete lecture will be available at our website. You can go ahead and download that PDF for your reference, or if you need to practice these questions once again, you can visit our site adityclasses.co.in. So you can visit this website. You'll find PPTs, PDFs, practice questions, solutions of these videos will be available at adityclasses.co.in. You can visit there. You can leave your comments, you can leave your queries, you can leave your questions in the comment section. And yes, don't forget to subscribe for our latest updates. Next time when we meet, we'll go ahead and solve a proper linear problem using the graphical method. Right? Thanks for watching. Bye bye.